Hello, we are going to be working through the practice midterm. So this will give you the answers, but it'll also give you a detailed explanation for how these are worked. So if you have questions, you can watch these. I would highly advise that you try to work this by yourself without any notes or any help and see how many you can get through. And then check this video and see the ones that you didn't understand, look at the explanation, and make sure you understand how to work all of these types of problems. So number one, it has two parts. You're given 2 points, P and Q. For part A, you want to find the midpoint of the line segment. And for part B, you want to find the distance between the 2 points. So for the midpoint, remember that's just the point in the middle of the line segment. And so what you're really doing is finding the average of the x's and the average of the y's. And so what you're going to do is you're going to add the 2 x values and divide by 2, and add the 2 y values and divide by 2. And that's going to give you an ordered pair that is the center, right, the midpoint of the line segment. So we have 4 and -3, and we have 5 and 6. And so that's going to be 4 minus 3 is 1, so 1/2. 5 plus 6 is 11. So 1/2 and 11/2 is the ordered pair. So that is the midpoint of P and Q. Okay. For part B, we're going to find the distance between the 2 points. So the distance formula, you want to subtract the 2 x values and square it, the difference, and then add that to the difference of the 2 y values and square that. So we have -3 minus 4 squared plus 6 minus 5 squared. So that's going to be -3 minus 4 is -7. And then 6 minus 5 is 1. So -7 squared is 49. 1 squared is 1. So that will give us the square root of 50. Now, more than likely, they're going to want you to fully simplify your radical. That's what I would expect when you were doing this. So that means you need to do a prime factor tree. So 50 can be broken down into 2 times 25. 25 can be broken down into 5 times 5. And so remember, your pairs come out and your singles stay in. So this is going to reduce. 5 comes out, 2 stays under. So 5 square root of 2 would be the distance between points P and Q. All right, for the second problem, given the points 4, 5, and -3, 6, we're going to do the following. So the first one, we're going to find the slope of the line. So when you find the slope of the line, you have a formula for that. So it's the difference of y's over the difference in x's. So 6 minus 5 over -3 minus 4, which is 1 over -7. So your slope is -1/7. Now, all these formulas are given to you at the top of this review, but you have to have these memorized. So make sure you memorize the formulas. All right, part B. Find an equation of the line passing through the points P and Q, and write this equation in point-slope form. So first of all, you need to know the different forms. So point-slope form is y minus y1 equals m times x minus x1. All right, so now you just need to know what to plug in where. So y sub 1 and x sub 1 are one of the points. You can pick a point. So we can pick point P, and then m is the slope that you found in part A. So that would be y minus y sub 1 is 5 equals m, -1/7, times x minus x sub 1, which is 4. Since they want it in point slope form, that is your answer. You don't have to do anything to transform it at all. Remember, if they wanted it in slope intercept form, then you would move the 5, you distribute the slope and move the 5 over to get the y by itself. But this is point slope form, so that's it. All right, number 3. Consider the quadratic equation. X squared minus 6x equals 27. Solve the quadratic equation by factoring. And part B is solve the quadratic equation by completing the square. So in order to get this right, you have to use the method described in the directions. If you don't, you will not get credit. That's the whole point of these problems. It's not just about can you solve it, it's about can you solve it in a specified way. So to solve the quadratic equation by factoring, remember to do that, you need to set it equal to 0. So the first thing you want to do is subtract the 27 from both sides. So that'll get us x squared minus 6x minus 27 equals 0. There's 3 terms, and there's not a number in front of the x squared, which means it's understood to be a 1. So we can do the quick factoring method. X squared breaks up into x and x, and then we need to figure out what multiplies to get negative 27 and adds to get negative 6. So that will be negative 9, positive 3. Negative 9 times 3 is negative 27, and negative 9 plus 3 is negative 6. So that would be our factors. And now remember, you set each factor equal to 0 and solve because of the 0 factor property. So now you add 9 to both sides. You get x equals 9. And here you subtract 3 from both sides. So you get x equals negative 3. So our two solutions here are 9 and negative 3. Okay. Now we want to solve the equation using completing the square. Now, clearly, since we're solving the same equation, we should get the same answers. So we already know what answers we should be getting. It's just a matter of solving them the way they ask. If we don't get the same answers, then we know we did it wrong and we can try it again. Okay? So completing the square. For completing the square, we want anything with an x to be on the left, and we want the constant on the right. So it's set up for that as it is. And then what we want to do is we want to put a plus blank here and a plus blank here. And we're going to fill in the blank so that what's on the left is a perfect square trinomial. So remember, that means we're going to have some binomial squared, like x plus 2 squared, or something, of that nature. So let's see. Remember how you fill in the blank? You take b, which is the number in front of the x, and you divide it by 2. So negative 6 divided by 2 is negative 3. And then you square it. So negative 3 squared is 9. Since you're squaring it, remember it's always a plus. That's why it's always plus blank on each side. And remember to put the plus blank on each side because that keeps the equation balanced. And so now we can factor. So the left-hand side is going to factor into something squared equals 27 plus 9 is 36. Now, this is going to be x, and then remember that what it's going to be in here, the factor, is always what you got here when you divided by 2. So it's going to be minus 3. So x minus 3 squared. The reason is because negative 3 times negative 3 gives us the positive 9, and negative 3 plus negative 3 gives us the negative 6. Now we have it set up to use the square root property, so we can take the square root of both sides. Don't forget to put a plus or minus. And so now we will have x minus 3 equals plus or minus 6. Okay, last step, add 3 to both sides. So we get x equals, the most common mistake is people will just put plus or minus 9. That is not correct. This is a 3 plus or minus 6. This gives us 2 answers. 3 plus 6, which is 9. 3 minus 6 is negative 3. So see, if you said plus or minus 9, you would have gotten one of the answers right and one of the answers wrong. So we got our 2 answers of, negative 3 and 9. Same thing as above, right? But just did it in a different method. So make sure you know how to use all of the different methods. You also should know how to use the quadratic formula, and you should also know how to do one with the square root property, which is built into the completing the square process. But if it just says square root property, you should know how to do that as well. All right, solve the equation. So we need to solve for x. Remember, when you have a radical, what you're looking for is the radical isolated on one side of the equal sign? Is it by itself? Yes, it is. Everything on the left is under the radical. So at this point, to undo the radical, I can square it. So the square undoes the square root. So I'm going to just be left with 4x plus 28 on the left. And on the right, I have x plus 1 squared, which is the same as x minus 1 squared. And so that's the same as x minus 1 times x minus 1. So I've got to FOIL that all out. So 4x plus 28 equals x squared minus x plus 1. Combine like terms on the right, I will get x squared minus 2x plus 1. Now I have a quadratic equation. So I want to move everything to one side and set it equal to 0. Since the x squared is already positive where it is, I'm going to move everything to that side. So I'm going to subtract 4x from both sides, and I'm going to subtract 28 from both sides. So that'll give us x squared minus 6x minus 27 is equal to 0. And now I'm going to try to factor that. So this one will factor into x minus 9, x plus 3. Actually, I think this is the same. It ends up being the same quadratic we had above. So negative 9 times 3 is negative 27, and negative 9 plus 3 is negative 6. And so now we can solve, by setting each linear equation equal to 0. So we're going to get the same thing we did before, a 9 and a negative 3. Okay. All right, so a lot of you on your exam are going to be working and like, oh great, got the answers, done. No, don't forget to check. Whenever you start with the square root in your equation and you solve it by getting rid of the square root, you have to check your answers because one or more of them may not work. If you don't check, you're probably going to get this wrong. So let's first check x equals 9. So it means I'm going to plug 9 in everywhere where there's an x into the original equation. That's important, the original equation. All right. So we have 4 times 9 is 36 plus 28. That's going to be 64, which is 8. And then 9 minus 1 is 8. So 8 equals 8. Okay, so 9 works. So that's definitely an answer. Now I'm going to check x equals negative 3. So we're going to plug in negative 3 everywhere we see an x. Okay, so I have 4 times negative 3 is negative 12. Negative 12 plus 28, that's going to be 16. And the square root of 16 is 4. Negative 3 minus negative 1 is negative 4. So is 4 equal to negative 4? No, it's not. So that is not a valid solution. So the only solution to this equation is 9. So notice if you did not check, you would put both answers in. You would probably get very little credit for that because a big part of this problem is, do you know to check for extraneous solutions? Okay, so let's look at the next one. Number 5, solve inequality and express your answer in interval notation. So this is an inequality and it's an absolute value inequality. So what you want to do here is first make sure the absolute value is by itself, and it is on the left-hand side of the inequality symbol. You want to make sure you're comparing it to a positive, because remember, 0 or negative are special cases. So this is compared to a positive, And so then the next thing you want to look at is this a greater than or a less than symbol? So this is a greater than symbol. So we have different methods to deal with a less than versus a greater than. So the greater than, what you want to do is split it apart into two inequalities. So the first one is negative 3x plus 1 is greater than 10. So the first inequality you're going to completely leave as is. This second inequality, negative 3x plus 1, is less than negative 10. You flip the inequality and you change the sign. That's always the way you do these. The first one you change nothing other than dropping the inequality symbols. And the second one you change the sign, flip the sign. And now we're just going to solve each of these inequalities. So subtract 1 from both sides. We get negative 3x is greater than 9. Divide by negative 3. Okay, now here you need to make sure you remember when you divide by a negative, you always flip the inequality symbol. It always changes the relationship between the two sides. So this is now going to be x is less than negative 3. Okay, so again, we flipped the inequality symbol because we divided by a negative. When you multiply or divide by a negative, it changes the direction of your inequality symbol. So in the other one, we're going to subtract 1 from both sides. So if negative 3x is less than negative 11, now we want to divide by negative 3. Again, we're dividing by a negative, so that's going to flip the symbol. So x is greater than a positive 11/3. So now we want to express our answer in interval notation. So I would suggest making sure you also know how to graph this on a number line. So I'm going to do that. And I also think that helps with the interval notation. So here's my number line. You put your important points or your boundary points on the number line. So negative 3 and 11/3. Okay? And clearly the negative 3 goes to the left of 11/3 because it's negative and the 11/3 is positive. And now you have to figure out how to shade. So for shading, x is less than negative 3. It's pointing to the left, so you color in to the left. And for 11/3, x is greater than 11/3. It's pointing to the right, so you shade to the right. Now for both of these boundary points, since it's a strict inequality, there's no or equal to sign under it, you're going to have a parentheses. And so now to write the answer in interval notation, you're just translating exactly what's on the graph into interval notation. Remember, you always put the smallest value first in interval notation. The order matters. So for the first interval, you have negative infinity to negative 3. So that's, let me make sure it's clear. That's that interval, right? And then for the second interval, you have 11/3 to infinity. And so you write each of those intervals down and you use a union symbol to connect them. And that is your interval notation for this solution set. All right, so for this next one, we're going to solve this equation. So we start with this rational exponent, x plus 7 to the 4/3 equals 81. What I would really encourage you to do is first start by rewriting this in radical notation. And this is so that when you're working through it, you don't somehow forget a plus or minus if you actually need it. So remember that a rational exponent, the top number is the exponent and the bottom number is the radical, the root, the index. So when we rewrite this, we're going to have x plus 7 under the radical. And then we're going to have the exponent is 4. Oops. And the index, or the root, is 3 equals 81. So we're just rewriting this in radical notation. And so now we want to start trying to get rid of everything. So the first thing we can get rid of is the 4th power. So the opposite of the fourth power is the fourth root. So we're going to take the fourth root. Now, if you're taking an even root, like a square root or a fourth root, you have to remember to put the plus or minus. A lot of times, this is what's forgotten when you just raise this to the opposite power, like raise it to the 3/4 power. People end up getting one answer, but they don't get the other one. So the fourth root undoes the fourth power. So these kind of cancel out here. And so you'll be left with the cube root of x plus 7 is equal to, plus or minus, the fourth root of 81 is 3. All right, and so now we need to get rid of the cube root. So we're going to cube both sides. Okay, so we have, we're going to cube both sides, and whether it's a positive or negative, it's going to end up being whatever it was, so you'll still have the plus or minus. The power of 3 and the cube root undo each other, so we are left with x plus 7, and then we have plus or minus 3 cubed is 27. So 3 cubed is 27, and negative 3 cubed is negative 27. And now we're going to get the x by itself, so we subtract 7 from both sides, and we get x equals negative 7 plus or minus 27. I always put the plus or minus thing last. I just think it makes the most sense there. And so then we have our two solutions. We have negative 7 plus 27 and negative 7 minus 27. So the negative 7 plus 27 is 20. And the negative 7 minus 27 is negative 34. So those are our two solutions. So make sure you realize we have two answers here. It's very common for people to not do it this way, and they end up with only one answer. Okay, so number 7. Find the domain of the function and express your answer in interval notation. So remember that for the domain, you're looking for a couple of special cases. Remember, there are restrictions on the domain when you have a fraction, because the bottom or the denominator cannot be 0. And then you have a restriction when you have a square root, because it has to be non-negative. It has to be 0 or positive. So we actually have both in this scenario. We have a fraction and we have a rational or a radical. So we want to set what's under the radical. Usually what we do is we say, okay, that has to be greater than or equal to 0, because it can be 0 or positive. But since this radical is in the denominator cannot be 0. So instead of having it greater than or equal to 0, we just want it to be greater than 0. If it's not equal to, then that takes care of the denominator as well. And now we're just going to solve this. So plus 7 on both sides. So x must be greater than 7 for this domain, for this to work. Okay, it has to be bigger than 7. So we want to write that in interval notation. So if x is greater than 7, that means it could be 7 or bigger. So it's going to be from 7 to infinity, both parentheses. So there is the domain written in interval notation. Okay. Yeah, number 7. Okay, number 8. Use the graph of f of x to evaluate the expressions. Okay. So we have 4 parts here. So we have f of 1. Okay, so for f of 1, remember what they're giving you here is the x value. Because remember, this usually looks like f of x. So the x value is 1. And they want to know what's the y value when your x value is 1. So when x is 1, y is 0. Okay, part B. When x is 4.5, 4.5 is like right here. We have to move all the way up to here, right? So that looks like it's probably about 2.2 2.25 maybe is a good guess. I mean, on these, if you're pretty close, then you're going to be fine, okay? Maybe it's 2.25. Okay, so you're looking for the y value, right? So the y value is like right up here. So that's right over the 2.2 line. So I said 2.25. Okay, f of 2.5. So we're going to look for 2.5, which is right in here. So what's the y value? Well, that looks really about the same, 1.25. So if you're wondering how I know it's 2, here's what I'm looking at. I'm looking at the number of intervals between 1 and 2. So there are only 5, right? 5 dashes, 1, 2, 3, 4, 5. So that means to split up tenths, right? It would have to be 1, 1.2, 1.4, 1.6, 1.8, and then 2. That's how I know that. And so since it's slightly above that 1.2 line, I'm saying 1.25. Okay. Now I want f of 1/2. So f of 1/2 is like here. So I'm going to go up here, and I'm going to guess that's about 0.25. So 0.25. Okay, so remember, what you're doing for all of these, if they're giving you the x value, you're just going to the graph and finding the associated y value. Number 9, consider the functions f and g defined by the following tables. Evaluate the following expressions. Okay, so we want to use the tables. Remember that this sum is the same as f of 4 plus g of 4. And so I can find each of those values in the table. So f of 4, if x is 4, then f of 4 is 2.3. So 2.3 is f of 4. If x is 4, g of 4 is 3.31. So 3.31. And then I add those together, I get 5.61. So that is the sum at 4. Okay, part B. We want to find the product at 5. So let's just do this in green. So this is the same as f of 5 times g of 5. Okay, so f of 5, when x is 5, f is 4. So this is 4. When x is 5, g is 3. Okay, and then 4 times 3 is 12. All right, red, we have the quotient. So f of 3 over g of 3. F of 3. So when x is 3, f is -1. When x is 3, g is +1. So -1 divided by +1 is -1. Okay, and then the last one, part D, they want us to do a composition function. Remember that this means g of f of 5. So what we're going to do first is we're going to find f of 5. So we completely ignore the g for now. Let's just look at f of 5. So f of 5, let me erase all these other colors so it's easy to follow what I'm doing here. Okay. So f of 5, when x is 5, f is 4. So this is 4. So now we're going to be looking for g of 4. Okay, so now I'm going to be looking for that. So when x is 4, g is 3.31. So my answer is 3.31. So this is, you're kind of doing one thing after another. You're not finding them separately and then combining them like we were in A, B, and C. You're using one to find the other. Okay, number 10, solve the equation. So you're going to notice this is an x to the fourth. So we're going to have to figure out how to get this into some kind of a quadratic that we can factor. Notice that we can factor out a common factor. Do you see how they all have an x squared in common? So we're going to divide that out. So x squared. And if we divide out x squared and see what's left, we will have x squared minus 6x plus 27 equals 0. And so now we want to figure out what works here. So x squared minus 6x plus 27. This looks like it will factor, but actually I don't think it will because of the plus 27. So maybe we can use the quadratic formula. We haven't done that yet. So we have two different things we need to look at here. We have the x squared equals 0, and then we have x squared minus 6x plus 27 equals 0. So for the x squared equals 0, we can square root both sides. Plus or minus makes no difference on a 0. Either way, it's 0. So x equals 0. So there's one solution. Okay? And if we're being technical, it's a multiplicity too, if you remember learning about multiplicities, right? Because we have x squared equals 0. So now we're going to solve the other one. So to solve this quadratic, we're going to use the quadratic formula. So x equals the opposite of b, so that would be the opposite of negative 6, so it would be positive 6, plus or minus b squared, so negative 6 squared, minus 4 times a, which is 1, times c, which is 27, all over 2 times a. And so in case you don't remember, a, b, and c are the numbers in front of your x's and your constant. So the number in front of x squared is a. Since there's nothing there, it's understood to be a 1. The number in front of the x is the b. And the constant, the number by itself, is the c. So that's where I'm getting these from. And this formula is on the top of this document. But remember that you have to have it memorized for your midterm exam. So get started on that. Now all I need to do is simplify this. And so if I do that, I will have 6 plus or minus the square root. Negative 6 squared is 36. There's only one negative, so it's going to stay negative. And then 4 times 27. That's going to be 108. Okay, over 2. And then I have to simplify what's under the radical. So 36 minus 108 is negative 72. So 6 plus or minus the square root of negative 72 all over 2. Okay, and so now we want to simplify what's under the radical. So the 72 is not a perfect square, but it could be reduced or simplified. So 2 times 36, and that's 6 times 6. And I'm going to stop there because I noticed the 6's are pairs. So the 6's will come out and the 2 will stay under. So this is 6 plus or minus 6i. This negative comes out as an I, 2 over 2. So again, the 72 splits up into the 6 on the outside and the 2 on the inside. And then don't forget to take this negative out as an I. So that comes here, right? Okay, and so now, since I can reduce, right, each piece is reducible by 2. So I'm going to do that. So 3 plus or minus 3i square root 2. So there's 2 more answers. All right, so now we have 3 solutions, 3 different numbers. So our solutions are 0, 3 plus 3i square root 2, and 3 minus 3i square root 2. And I would be more than okay with you just writing the plus or minus if you want, instead of separating it into two different answers. But I want to make sure you realize that's two different answers. Remember, the 0 is technically a multiplicity of 2, so that matches up with the 4 answers we should expect because the exponent was a 4. All right, number 11. Determine if the function is even, odd, or neither. So first you need to remember how you show this. So a function is even if f of x is equal to f of negative x. A function is odd if f of x is equal to negative f of negative x. So we're going to build off of the even first, check even, and then we'll check odd. And if it's neither of those, then we're going to choose neither. So f of x has to equal f of negative x. So what we want to do is find what f of negative x is. So this is to check even. If it's the same as what we originally had, then it's even. So everywhere where there's an x, we're going to plug in a negative x. Okay, and so we're going to simplify. So a negative x squared is just going to be x squared because the squaring of the negative makes it positive. So 3x squared. And then this negative in the absolute value symbol, that will become positive when you take it out of the radical, out of the absolute value symbol. So that's going to be plus 3 absolute value x. Since after simplifying we got the original f of x, notice that these are exactly the same, right? All the signs are the same, everything is the same. That means that this is an even function. So we can stop there and just say it's even. Okay, so for part B, we want to know if it's even or odd. So we're going to start the same way. We're going to start by checking to see if it's even. So everywhere where there is an s, whoops, I should have an s. Everywhere where there's an s, I'm going to plug in negative s. So that will be 4 times negative s cubed minus 7 times negative s. And so now this negative s cubed, since it's an odd power, that negative is going to stay. So we're going to have negative 4s cubed, and then negative 7 times negative 7s. I think my voice cut out there for a minute. And so now what we're going to do is simplify. We can't, so that's it. Notice that these are not the same, right? These are not the same. The signs are different. Oh, and I made a mistake here. That should be a plus 7s, right? Because the negative 7 and the negative s make a positive. Okay, so now I was saying the signs are different. So this is not even. That's what I just checked. So now what I want to do is check to see if it's odd. Okay? So to check to see if it's odd, you want to get the negative f of negative x, or s in this case. So basically what you want to do is, if you look at the last thing that we just did, f of negative s, that's this. All we're doing is adding a negative to the front. So what we want to do is we want to take the answer that we got last and then just distribute a negative. So we're going to negative what we just had. What the heck just happened? Okay, let me try this again. We want to do negative. Oh my gosh, it just totally whited that out. I don't know why it did that. Okay, let me write this back real quick. This is negative 4s cubed plus 7s. Okay, so negative that. So negative 4s cubed plus 7s. And we're going to distribute this negative and see what we get. So this will be positive 4s cubed minus 7s. Now notice that this is exactly the same as what we had. All the signs match. So this is correct. So this is an odd function. Okay? All right, number 12. Find the inverse of the function. So first you need to make sure that you realize, is it 1-to-1 or not? Okay, so as I was saying this, you need to make sure that your function is 1-to-1. This is a 1-to-1 function, so we can go ahead and find the inverse of it. So remember, to find the inverse of a given function, you're going to switch the places of the x and the y, and you're going to solve. So g of x is the same as y, so I'm going to write y here. So to switch the places of x and y, I'm going to have x equals -1 over y plus 2. And then the goal is to solve for y. So first I need to get the y plus 2 out of the denominator. So I'm going to multiply both sides by that. So that'll get that out of the denominator there. So now I have to distribute the x. So I'll have xy plus 2x is equal to -1. I want to get the y by itself. So subtract 2x from both sides. So I get xy equals -2x minus 1. Now I need to divide by x, and so I get y equals, -2, and then minus 1 over x. Or I guess you could just leave it as -2x minus 1 over x, but I just simplified. So the -2x over x gives you -2, and then the -1 over x gives you minus 1 over x. Okay. Now you want to write it in the inverse function notation. So instead of having a y, you just want to write g inverse of x is equal to -2 minus 1 over x. And that would be it. Okay. Number 13. Let f of x equal x squared plus x and g of x equal 2x plus 1. Compute the following. Simplify your answer as best as possible. So f of g of x and g of f of x. All right, so this is the composition of functions. You're folding one into another. So here what we're doing is we're taking g of x and we're plugging it into f. So we want to take g of x and we want to plug it in everywhere we see an x in the f function. So this is going to be 2x plus 1 squared plus 2x plus 1. Okay, just plugging that in. And now we're going to simplify. So 2x plus 1 squared, remember that you have to write that down twice and multiply it all out. And then you still have to add that other 2x plus 1 at the end. And so now we're going to have 2x times 2x is 4x squared plus 2x plus 2x plus 1. And then bring down the 2x plus 1. So now I have 4x squared. I'm going to combine everything that's like. So I have 2x, 2x, 2x. So that's going to give me 6x. And then I have 1 and 1 is 2. All right, and I've combined all my like terms. That's as much as I can do. So that is the composition, f of g of x. That's it. Okay, and so now I'm going to do the kind of the opposite or the backwards version of that. I'm going to plug f, the whole function f, into g. So everywhere, let's see. Let's erase what I have up here. Everywhere I see an x, take the whole f function and plug it into g everywhere I see an x. So we're going to have 2 times x, which is now going to be x squared plus x plus 1. So distribute the 2. So I'm going to have 2x squared plus 2x. Bring down the 1. There's no like terms here, so there's nothing else I can do. So this is it. Notice we did not get the same answer, so that just shows that order matters when you're doing composition of functions. You have to make sure you do them in the correct order. Okay, number 14. Mrs. Smith wants to pave a walkway around a perimeter of her garden that measures 8 feet wide and 15 feet long. Find the width of the walkway if the total perimeter is 66 feet around the outside edge. Okay, so we're going to assume that it's a rectangular garden. So it's 8 feet wide and 15 feet long. So let's try to draw a diagram and try to figure out exactly what's happening here. So we have a garden. Okay, so here's the garden. And it says the garden that measures 8 feet wide and 15 feet long. So 8 feet wide, 15 feet long. That's the garden. And then we're going to add a walkway all the way around the outside of the garden. And so we know that the perimeter of the black, right, the perimeter of the outside edge of the walkway is 66 feet, okay? That's the black. But we don't have the measurements for the black. We have the measurements for the blue. So the length and width of the blue are 15 and 8. We want to find the width of the walkway. So we're ultimately trying to find is this distance right here. So we're trying to find the width of the walkway, which is that distance. Notice that the width is also over here. Since it's going to be a walkway that we assume is regular, right? It's going to be the same amount on all the sides. That's going to be X. If I wanted to know now what this black width is going to be, I could use all those pieces that I've just drawn to find that. Since the width of the blue is 8, and these two little red pieces are X, if I added all those together, that would be the same length as this full black side, right? The two pieces of walkway plus the 8. So that would be 8 plus X plus X. So it would be 8 plus 2X or 2X plus 8. So now I know the width of the walkway. So now I'm going to do the same thing for the length of the walkway. I have 15, but then I also still have the two widths of the walkway. I have this width is X, and this width also has to be X because it's uniform all the way around. And so we're going to have two X's and a 15. So 2X plus 15 is the length of the outside edge of the walkway. And now we know the perimeter of that is 66. So to find the perimeter, you add up all the lengths of the sides. So you have two lengths and two widths. So if we add it all up and set it equal to 66, we'll be able to solve for X, which is what we're trying to do. So we have 2X plus 8 plus 2X plus 8 plus 2X plus 15 plus 2X plus 15 is equal to 66. So I added up all the sides and set it equal to 66. And now I need to go through and get all my like terms. So I have 2X, 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 2X. So it's 2, 4, 6, 8X. And then I have 8, 8, 15, and 15. So it's going to be 30 plus 16. That should be 46. So plus 46 is equal to 66. And now I'm going to finish solving that. So subtract 46 from both sides. So that'll be 8x equals 20. Divide by 8. So x equals 2.5. So 20 over 8, which reduces to 10 over 4, which should be 2.5. Okay, so what did we just answer? X equals 2.5. Remember, in our diagram, X stood for the width of the walkway. That is what we were trying to find. So we're done here with this answer. So to me, setting this up is the hardest part because you have to figure out all the pieces and where the heck to label stuff. That's the most confusing part. The solving wasn't that bad once we had it, is getting it set up that way. So just kind of look at how I set this up and maybe practice again. Remember, there are more examples like this in the free textbook online that we use. So check there if you need more examples. All right, number 15. Dr. Pollard poured 22 grams of 7% alcohol solution into a large mixing container. He had plenty of 16% alcohol on hand. Let X represent the number of grams of the 16% solution. How much of the 16% solution did he need to pour into the container in order to have a 12% solution for his lab experiment? Round your answer to the nearest tenths if necessary. So let us kind of make a chart in order to get our information together. So what I want to do is I want to be able to keep up with how many grams were used for each percentage solution, right? So for each alcohol solution. Okay, so the first thing I see is 22 grams of 7% alcohol. So that's the first thing I'm going to enter into my chart. So there was 22 grams used of the 7% alcohol. I'm going to go ahead and write my 7% as a decimal because that's what I'm going to have to use when I write my equation. Okay, so he's mixing that with an amount of 16% solution because it says how much of the 16% solution did he need to pour into the container in order to have a 12% solution. Okay, so he's mixing this with the 16% solution. And it says how much, meaning we don't know how many grams he used, so we can say he's X grams of a 16% solution. So as a decimal, that's 0.16. And now we're going to look at the total. So these are the mixtures. He's mixing the red plus the blue, and he's going to get the green, as I'm going to write it in green. So our mixture needs to be 12%. And we don't know how much he mixed there either. So mixture is 12%. Now, if he used 22 grams of red and X grams of blue, and he's mixing them together, we can find the total by simply adding those two together. So by doing 22 plus X, or X plus 22, that's going to give us the number of grams used for the mixture total, because we're just adding these together. So X plus 22 will be the number of grams he used of the green, or the number of grams he gets of the green, right? Because that's actually the solution in the end. Okay, so let's use this information now to write our equation. So what we want to do is we want to know that we're adding this plus this equals this. So the two things we're mixing together gives us our solution. So we're going to do 22 times 0.07. So you're just going to multiply straight down plus 0.16 times X plus 0.12 times X plus 22. And now we're just going to solve this equation. So 22 times 0.07. So it'll take me just a second as I get my calculator here. Okay, so 22 times 0.07 is going to be 1.54. Okay, now even though it says to round your answer to the nearest tenth, it wants your final answer to the nearest tenth. You should not round until the very end. 0.16x is equal to, we need to distribute this 0.12, so it'll be 0.12x, and then 0.12 times 22 equals 2.64. So plus 2.64. Okay, and so now we want to solve this equation. So we want all the x's on one side and the numbers on the other. So I can subtract 0.12x from both sides. That gets all my x's on the left, and I can subtract 1.54 from both sides. That gets my constants on the right. So when I do that, the 0.16 minus the 0.12 is 0.04. So 0.04x is equal to 2.64 minus 1.54 is 1.1. Okay, and then the last step is to divide by 0.04. Okay, so 1.1 divided by 0.04. And so when we do that, we get 27.5. So that came out to the 10th place anyway. So that's X. Is that what they asked us to find? How much of the 16% solution did he need to pour into the container? That's what we had X stand for, so this is correct. So 27.5 grams is the amount he needed to pour of the 16% solution. All right, so when you're doing these percent problems, make a row. This is how I like to do it. I like to make a row for the unit of measure, so if it's grams or pounds or whatever it is, and then a row for the percentage as a decimal. And then you can create your equation by simply multiplying the values together and setting it up like that. Okay. 16. Use the vertical line test to determine if the relation is a function. That's part A. Part B is use the horizontal line test to determine if relation is 1-to-1. Okay, so this is pretty simple. You should know how to use both of these. So the vertical line test is you simply drawing a vertical line through your graph. Okay. If it passes through more than once, that means it is not a function. So this is not a function. So at any point, if I can draw a vertical line on the graph anywhere that it passes through more than once, it's not a function. Part B, use the horizontal line test to determine if a relation is 1-to-1. Horizontal line test, so it's kind of telling you what to do here, right? Here you're going to draw a horizontal line, and if the horizontal line passes through more than once, it's not 1-to-1. So this is not 1-to-1. Okay? So simple enough. Number 17, determine the domain and range of the functions graphed below. Express your answers in interval notation. So remember, the domain is left to right and the range is bottom to top. So the domain, the farthest left it goes is 0 and the farthest right it goes is 3. So your domain is 0 to 3. Now look at the dots. The dot on the left is open, so an open circle means parentheses. The dot on the right at the 3 is closed, so that means a bracket. So there's your domain. Okay? Now your range is bottom to top. So how far down does it go and how far up? How far up does it go? So this goes to right about here. And so you need to make sure you figure out where that is. It's right about in the middle of 1 and 2. So I would say 1.5. I think that's a reasonable estimate there. And so the bottom is 0. So your range is bottom to top. So your range is going to be 0 to 1.5. The 0, again, it's open circle. The 1.5 is closed circle. So parentheses on the 0 and a bracket on the 1.5. Part B, again, you're looking for the domain and range. So the domain is left to right. So the farthest left your graph goes is here. So that's at 0. The farthest right your graph goes is here. That's at 2. So your domain goes from 0 to 2. Both are closed in or solid circles, so you're going to have brackets. Your range, you're simply looking bottom to top. So the lowest your graph goes is here, which is a -1, and the highest your graph goes is here, which is a 1. So your range is -1 to 1. So again, domain is X values, left to right. Range is Y values, bottom to top. Find the average rate of change of f of x over the interval 0 to 3. So for this, what you want to do is you want to find the y values of these you're going to plug the 3 and the 0 in for x. So you're going to find f of 3 is equal to 3 squared plus 1. So 3 squared is 9. 9 plus 1 is 10. So that's 10. Then you're going to find f of 0. So f of 0 is 0 squared plus 1, which is 0 plus 1, which is 1. And so the average rate of change is simply subtracting y values over the x values. So you would have 10 minus 1 over 3 minus 0. That would give you 9 over 3, which is 3. So the average rate of change over the interval 0, 3 is 3. Number 19, write your answer to the following complex number computations in the form a plus bi, where a and b are real numbers. So for a, you're just trying to distribute these, so you're multiplying them together. So you're going to distribute the negative 4, and then you're going to distribute the 3i, and then you will combine like terms. So negative 4 times 2 is negative 8. Negative 4 times negative I is plus 4i. 3i times 2 is plus 6i. And 3i times negative I is negative 3i squared. So now you want to combine your like terms, and remember that you cannot have an I raised to a power, and it's not considered simplified. So this I squared, remember that that becomes a negative 1. Okay, so we have negative 8, 4i and 6i would give me 10i, and then I have negative 3 times negative 1 would give me plus 3. And now the negative 8 and the 3 are both real parts, so I can add those together. So that would give me negative 5 plus 10i, and that would be the solution. Now, in the directions, it says to write it in this form. Even if it didn't say that, you should know to write it in that form, because that is considered simplified form of a complex number. So make sure you always write your real part first and your imaginary part second. So in other words, remember, if I would have written this like this, 10i minus 5, even though that is the same, it's not in the correct form, you would lose points for that. So make sure you write it in the correct order. Part B, for some reason, these are the ones that usually get students. This division. So you're thinking, okay, divide, and sometimes that doesn't trigger your mind to do the right thing. What you're trying to do here really is get rid of the I on the bottom. You can't have an I in the denominator. So what you want to do is you want to multiply by the complex conjugate. So remember, if you have a complex number like this, you're going to multiply by the same two things, but a different middle sign. So instead of 2 plus I, you're going to multiply by 2 minus I. So when you do that, you're going to multiply it all the way out on top and bottom. So 1 times 2 is 2. 1 times negative I is negative I. 3i times 2 is 6i. 3i times I is negative 3i squared. So that's what I get when I completely distribute out the top, right? Or FOIL out the numerator. On the bottom, I've got 2 times 2 is 4, minus 2i, plus 2i, minus I squared. Okay, so make some notes. Remember that the I squared becomes negative 1. We've got to remember that. We've got to remember to combine all of our like terms. So 2, negative I plus 6i is plus 5i. Negative 3 times negative 1 is plus 3 over 2i and negative 2i. Well, those are opposites, so those zero out. And then I have 4 minus a negative 1, which is 4 plus 1, which is 5. Okay, so I got more work to do. I need to combine my real parts on top. So 2 plus 3 is 5. So I'll have 5 plus 5i all over 5. And now everything is divisible by 5, so I can reduce to 1 plus 1i, which you don't write the 1 in front of the I. It's understood to be there. So 1 plus I. And that's it. So for this one, you have to remember the setup, right? What you're really trying to do is get rid of the I on the bottom. You do that by multiplying by the complex conjugate when you have a complex number on the bottom. Okay, we're finally to the last problem. Determine the X and Y-intercepts of this equation. All right, so remember, to find the X intercept, you let the other variable be 0. So if you're finding an X intercept, you let Y be 0. So that means 8x minus 9y, which is 0, equals 72. So that means 8x equals 72. Divide by 8. So you get x equals 9. So your x-intercept is 9, 0. Make sure you write your answer as an ordered pair, or it's not giving the x-intercept. Okay? Y-intercept. X is 0 now. So 8 times 0 minus 9y is equal to 72. So that's 0. So now we have negative 9y equals 72. Divide both sides by negative 9. So you get y equals negative 8. So your y-intercept is 0, negative 8. Again, make sure you write it as an ordered pair, or you're not giving the intercept. And that's all there is to that.